Okay, so in this video, we're going to look at a couple of more complicated examples of differentiation by first principles. The first example is f of x is equal to 2x cubed plus 7. So as with the earlier examples, the first derivative of x is given by the limit as delta x approaches 0 of f of x plus delta x. So everywhere we see an x, we need to put x plus delta x. So we have 2x plus delta x cubed, and the 7 stays there. Take away our original function, all divided by the small change delta x. So there are a couple of methods you can use in order to expand the cubic polynomial here. In this video I'm going to go with the Pascal's triangle. And Pascal's triangle basically tells us what the coefficient in front of each of the terms are going to be when we're expanding a polynomial. So since our term is cubic, we're going to need the fourth line of Pascal's triangle. So as an aside, we can expand this out as starting with x cubed. So the second coefficient is going to be 3, and then we reduce the power of x by 1 and increase the power of delta x by 1. And again, the coefficient is going to be 3, reduce the power of x by 1, increase the power of delta x by 1. And our last term is going to reduce the power of x by 1 to 0, and we're going to be left with delta x cubed. So now let's plug that in and see what we get. We have the limit as delta x approaches 0 of, we're going to have 2x cubed plus 6x squared delta x plus 6x delta x squared plus 2 delta x cubed plus 7. Take away 2x cubed, and then be careful because we're subtracting a positive number here. So we're subtracting 7. And as always, this is going to be over the small change delta x. So as always, there's a couple of terms which can cancel out. So we have a plus 2x cubed term here, and a minus 2x cubed term here. We have a plus 7 and a minus 7. And once again, we can factor out delta x. So what we're left with is going to be the limit as delta x approaches 0. And then factoring out delta x on the top, we have delta x times 6x squared plus 6x delta x plus 2 delta x squared. And then as always on the bottom, you have our delta x. So once again, these delta x terms are going to cancel each other out, and then we can substitute quite simply delta x equals 0 now. So this is going to go to 0, this is going to go to 0, and then what we're going to be left with is that f prime of x is equal to 6x squared. So as you can see, the method used is always the same. just becomes a bit more tricky when you have a higher power of x to deal with. So the final example we're going to look at in this video is f of x is equal to the square root of x. So as always, f prime of x is equal to the limit of some small change in x, delta x, approaches 0, of the function of f(x plus delta x). Everywhere we see an x, we replace with an x plus delta x. So we have an x plus delta x under this first square root term here, and then we're taking away the original function, which is just the square root of x, and as always, divide by the small change in x. Now this is where a lot of people get stuck. The next step, you need to use a relationship. A plus b times a minus b is equal to a squared minus b squared. So in this example, we're going to substitute a is equal to our square root of x plus delta x, and our b is just equal to square root of x. So here we have a minus b, and if we times by a plus b, this should give us a much easier term to deal with. So we need to times the top and the bottom of this fraction by a plus b, so that'll give us the first derivative of x is equal to the limit as delta x approaches 0. So on the top we're going to have a squared minus b squared, so we're going to have a squared minus b squared, so we're just going to have x plus delta x, that's a squared, and just subtract b squared, which is just x. Now on the bottom we're going to have delta x times by the a plus b factor that we had to introduce. So it's going to be x plus delta x plus square root of x. Now as always, a couple of terms can cancel out here, so we've got a plus x and a minus x. And on the top we're also going to be left with a delta x, just times by a delta x on the bottom. And then finally the equation is in a form where we can input delta x equals 0. So this will be 0. So what we'll be left with is the first derivative of x is equal to 1 over the square root of x plus the square root of x. It's just equal to 2 times the square root of x. And that's it. So in the next video, I'm going to be introducing the power law and showing you how you can use it to solve some of these basic differentiation problems. See you there.